On today's topic, we are going to discuss about only transformer concepts. Before going into the transformer concepts, we will just discuss about the Ohm's law. What is meant by Ohm's law? Today, whatever I am going to teach, whatever I am going to discuss, these points will be used for facility and property management people who is already working and who want to get job in facility and property management. They can also see this video. I am going to teach some good concepts and some good interview questions that will be asked during the interview. So please carefully listen. The first one is Ohm's law. What is meant by Ohm's law? Ohm's law is nothing but in a closed electrical circuit, voltage is directly proportional to current at constant temperature. The constant temperature is the main term. If you don't tell this at constant temperature, the entire sentence is wrong. So one more time I am telling, please listen. Ohm's law is nothing but voltage is directly proportional to current at constant temperature in a closed circuit. Okay, this is one thing. V is directly proportional to current. V is equal to I into R. V is nothing but volts. I is nothing but current. R denotes resistance of the conductor. R is also known as rho L by A. Rho is nothing but resistivity of the conductor. The resistivity of the conductor will differ depends upon the conductor which we are using for the transmission of electricity from one point to another point. If we use aluminum, then the resistivity of the aluminum is different. If you use copper, the resistivity of the copper is different. So R is equal to rho L by A. Rho is nothing but resistivity of the conductor. L is nothing but length of the conductor. If you want to transfer energy or transfer power from one end to another end, the length of the conductor is 100 meters, then the L value is 100 divided by A. A is nothing but cross section area of the conductor. See, for example, if you are laying any cable, the cable will be around 2.5 square mm or 1.5 square mm or 10 square mm, 16 square mm, 25 square mm. It may be anything. The A value denotes the cross section area of the conductor. If you are using 2.5 square mm cable, then 2.5 is the area of the conductor value. So with this, we are going with transformer concepts. What is meant by transformer? Transformer is a static device which can be used to transfer the energy from one circuit to another circuit without changing the frequency. This without changing frequency is the main term. If you don't tell this term, the entire definition is wrong. So transformer is a static device which is used to transfer energy from one circuit to another circuit without changing the frequency. So transformer has two circuits. One is primary circuit, another one is secondary circuit. There is no link between primary and secondary, even though the energy will be passing from primary circuit to secondary circuit through mutual induction. The mutual induction concept. Faraday's law of mutual induction. The principle of transformer. Now we are going into transformer parts. What are the parts of transformer? First, we have seen this one. Transformer ratio is defined as the ratio of secondary voltage to primary voltage, as I said. And the transformation ratio is indicated as K. If the K value is greater than 1, then the transformer is step up. K value is less than 1, then the transformer is step down transformer. So There are some, normally in primary we'll be using delta transformers. In the secondary side we'll be using the star transformer. So in the step down transformer in secondary side we'll be getting the neutral extra RYB neutral. In the primary side we'll be having only RYB phases. What are the parts of transformer? The first one is conservator. The conservator is mounted on the top of the main tank. The transformer has one main oil tank. Inside this oil tank, there are primary and secondary windings. So on top of this oil tank, the conservator was mounted. So it is filled with two-thirds of oil, and remaining volume is filled with the air. Why the remaining volume is filled with the air will be explained later. And the purpose of this conservator tank is it accommodates the expanded oil volume when heated due to transformer loading. When you load the transformer from 0% to 100%, the winding will get heat. Because of this winding heat, oil will get heat. Once oil gets heated, then oil will expand. This expanded oil will flow to the conservator tank. When load again come down, the oil will cool automatically. Again, the oil will transfer from conservator tank to main tank. So depends upon different loading conditions, the oil will go to the conservator tank. Again, it come back to the main tank. So this oil level can be seen with the side plus which was installed in the conservator tank. And second one is breather. Why breather is required? The breather is connected to the conservator tank with a small pipe, and it is filled with the silica gel. Normally silica gel color will be in bluish color. When it absorbs the moisture, it converts into pink color. The purpose of this breather is used to absorb the moisture in the atmosphere air before it entering into the conservator tank. So whatever the air I said in the conservator, the remaining portion of the conservator is filled with the air. How this air will go to the conservator tank? Through this breather. While going through this breather, the whatever moisture in the air will be absorbed in the silica gel, and only air will be passing inside the conservator tank. What transformer oil? What type of oil is used in the transformer? Normally, mineral oil will be used for transformer oil. It has two purposes, two advantages. One is it will be acting as an insulation for the winding. There are two windings, I said, primary and secondary winding. So this oil will be acting as an insulation between these two windings, and it will be using as a coolant. It cools the transformer with different load conditions. We have to do this oil filtration every year to remove the moisture content in the oil. The dielectric strength of this particular oil should be 40 kV for 40 kV for 11 kV transformers, and it should withstand for 1 minute. It should withstand for 1 minute. 40 kV should withstand for 1 minute. That is called BDV, breakdown voltage test. The oil should withstand for 40 kV for 1 minute. Then this particular oil is a good oil for transformer. And while testing, we have to collect the oil from the drain valve. First 5 to 10 liters we need to remove that oil. You should not take it for the testing because there are some moisture content will be there in the bottom of the tank, because the water density is more than the oil density. So whatever this water molecules will be settled in the transformer main tank. So while taking the samples for testing, We should avoid 5 to 10 liters of the oil and then we have to take the oil for the testing. And this oil should withstand 40 kV dielectric, 40 kV dielectric strength. Oil filtration and moisture handling. Oil filtration. Oil should be heated under the vacuum to remove the water and moisture. Under vacuum, boiling point of oil moisture drops to 70 degrees Celsius. Avoid heating oil beyond 70 degrees under normal pressure. This entire thing will be coming under the oil filtration. There is one equipment which will be having vacuum. The oil will be passing inside the vacuum and it will be heated up to 70 degrees Celsius. And explosion vent. The explosion vent is mounted on the main tank, which has the diaphragm inside, and any which is used for during the faulty conditions. If any short circuit occurred inside the transformer, then enormous heat will be produced in the winding. Due to this enormous heat, oil gets heated up and it will expand. The expanded oil will come out through this explosion vent by damaging the diaphragm. To maintain the transformer safe, otherwise it may lead to explosion of the main tank. If all holes are closed, there is a huge amount of heat pressure increased inside the tank. What will happen? The tank will explode. To avoid that issue, we'll be using the explosion vent. Oil temperature relay and winding temperature relay is used to measure the temperatures of the oil inside the main tank and winding temperature, which is also the sensors also placed inside the main tank. What is on-load tap changer? We call it as OLTC, which is used to increase the voltage levels. Depends upon our requirement. In load conditions, using RTCC, remote tap changing control. So OLTC is connected with the RTCC. In RTCC, we will be setting the required voltage for usage. So if the voltage is lesser than the set point, then the tap change will increase. Once we change the tap in the primary side, normally this tap changer was installed at the high voltage side because the current is less at high voltage side. So always OLTC will be installed at the higher voltage side. In the step down transformer, OLTC installed at primary side. In step up transformer, the OLTC is installed at the secondary side. What is Buckles relay? Buckles relay has two mercury switches. One is for alarm, another one is for trip. This Buckles relay was installed between main tank and the conservator tank. During faulty conditions, during internal fault conditions, the oil gets expanded and this expanded oil will flow to conservator tank through the Buckles relay. Depends upon the type of the fault. If it is a minor fault, leads to alarm. If it is a major fault like short circuit happen, then it leads to tripping of the transformer. That means isolating the transformer from the source to the load.